time for steel. Oh, I should have told this guy that I need him to trade. Crowns. So many crowns. don't get why these guys aren't wearing their uniforms. There's more than enough shit. Yeah, they have clothes, they just don't want to wear. Oh shit, did I? Winter. Oh boy, we got the ruler now. Holy shit. What are they all doing here? Planting sweet pods. Oh, wait. Oh, okay. Shit. I don't even know if I'm sealed off. I don't think I am anymore. Okay, I gotta make royal bedrooms and shit. Just use this area, I guess. This temple zone. Never have that many temples. Ten chat. Oh my god. 2, 4, 6, 8, 10. Why don't any of these count yet? Damn, none of these are good enough. Okay, the outpost liaison is happy.
Welcome to History for Granite. Join me to explore ancient Egypt. Together, we'll uncover secrets that only stones from antiquity can reveal. Please subscribe to the channel to show your support for this line of inquiry. That drives me to make more of this content for you. The Great Pyramid of Giza, famed for its record-setting size and precision in alignment, is full of peculiarities inside. One of the most vexing and confusing inner structures is the well shaft, and by extension, the small grotto that it intersects on the way down. What I find most frustrating about the well shaft isn't so much its confounding design, but rather how it serves as a get-out-of-jail-free card for so many poorly considered pyramid theories. For example, how did the builders seal the ascending corridor with granite plugs? Maybe they climbed down the well shaft. How did looters know where to tunnel in? Maybe they climbed up the well shaft. How do we know giants didn't build the pyramids? They probably couldn't fit through the well shaft. But in all seriousness, the well shaft does lend itself as an excuse to stop reasonable inquiry about a fascinating subject. How was the pyramid sealed, and how was it plundered later on? Compounding my frustration is that there is scant physical evidence for us to examine, because imagery within the well shaft is extremely rare and always poor in quality due to the absence of light and it being a constrained space. Despite these limitations, I think we can reach some reasonable conclusions about the well shaft, even if we can't yet satisfy every answer for its ultimate purpose and design. Let's start with a brief overview of its layout, which is quite interesting because there are several sections and they all differ from each other quite a bit. Starting from the top, the upper well mouth is cut into the western bench at the bottom of the Grand Gallery. Interestingly, the well mouth does not take up the entire space of this lowest block in the bench. Instead, it is only 68 centimeters long north to south, leaving an additional 57 centimeters of bench remaining on the northern side at the lowest point in the Grand Gallery. It's generally accepted that the original bench block here was standard for the Grand Gallery, making up the length of both the well mouth and the 57 centimeters of remaining bench below it. You can't infer too much from this design, however, because the builders may have found it easier and more structurally sound to install a standard block for the western bench and then cut into it for the well mouth. Leaving a gap for the mouth with a smaller stone supporting the bottom of the Grand Gallery might have been perceived as less ideal. The well mouth is the full width of the bench at 52 centimeters, plus another 15 centimeters of width into the wall of the Grand Gallery, making it nearly square. The well goes down less than a meter, then travels horizontally westward for another 1.4 meters before it opens to a square 68 centimeter aperture, which marks the point of its real descent. From this point, the well plunges vertically downward for 8 meters through the pyramid masonry. Then, the well makes about a 20-degree southward bend, so it is no longer vertical, for another 8 meters of distance before it reaches the foundation of the pyramid, where it meets the bedrock. The well shaft then sharpens its angle back to vertical for the first 5.2 meters of depth into the Giza Plateau. The upper half of this vertical section is not solid bedrock, but instead 10 small courses of brick-sized masonry that wall off a small grotto. The grotto's walls and ceiling are made of compacted small rubble, which suggests the 10 courses of masonry in the well shaft are put in place to protect the well from being clogged up from loose debris. The well shaft bricks being smooth and neat on the inner section, but rough and coarse on the grotto-facing side, add to the evidence that the well is the priority, and that this masonry was set in place from the interior. 2 meters below the grotto masonry, the well shaft once again bends horizontally to the south, this time at an even gentler slope. I can only estimate its angle from available diagrams at about 40 degrees less than vertical. After traveling another 26.5 meters down into the south, the shaft then steepens its angle once again to be only 15 degrees less than vertical. It then continues downward for a final 9.5 meters to its lowest depth. The lowest point of the well shaft is slightly deeper than the adjacent descending corridor, and it travels slightly upward and about 2 meters horizontally to the southeast to intersect the corridor. The lower mouth of the well shaft is smaller than the corridor itself and was originally well squared with sides measuring 79 centimeters. It has been pointed out by many observers that the well shaft would have intersected the descending corridor at the very bottom, where it becomes horizontal, if the well shaft's lower section had not changed to a steeper angle. So, what to make of this curious and winding path from the near bottom of the pyramid's substructure to its busiest intersection at the base of the Grand Gallery? Many potential uses have been suggested, including as a reference line to help control the pyramid's alignment as it grew, and increased air circulation for the excavation of the subterranean chamber. I even see potential for spiritual explanations when looking at the closest similar feature in the bent pyramid, the so-called chimney that rises next to the lower chamber. But let's focus on the notion of the well shaft as a potential escape route for workers or secret backdoor entrance for looters. Looking at the path the well shaft takes, it quickly becomes obvious that connecting a point above the granite plugs to the descending corridor was not its primary function. If this was the case, the well shaft would have connected to the descending corridor below the plugs, but not all the way down near the subterranean chamber. The path it takes is unnecessarily long, and its excavation must have been difficult. There is no evidence that the descending corridor was plugged up, and so making the well shaft entrance farther down doesn't add to its security. Another observation is that the well shaft isn't designed so as to be overly difficult to climb. If the builders really wanted the well shaft to be a one-way exit, it would have been designed entirely vertical. The last workers to leave could climb a rope down 40 meters of vertical shaft and then set the rope on fire, leaving a formidable challenge to any potential climbers because a fall would be fatal. Instead, most of the well shaft is reasonably accommodating to a fit person with a manageable grade and plenty of footholds which are presumably original. This suggests that the well shaft would be a huge security flaw if not sealed up in some way. Many historians assume the lower entrance was closed and camouflaged based upon this vulnerability. In my video on the prism stone of the Great Pyramid, I discuss how the lower well entrance was probably disguised in later times after the pyramid had long been opened. The addition of loose debris, sand, and moisture filling up much of the descending corridor would make hiding it much easier. 19th century explorer Giovanni Caviglia was the first known person to open up the well since antiquity, and even he could not find the lower entrance until he had almost finished excavating the descending corridor and the well shaft from above. But disguising the lower well entrance with the descending corridor in pristine condition would have been much more difficult, and there's no evidence to suggest it could or was done effectively. The only remaining method of securing the well shaft is closing it from above, and there is plenty of evidence to suggest this was accomplished. The damage to the upper mouth of the well is quite conspicuous, and shows evidence of destruction from above rather than from within. The 57 centimeters of bench below the well mouth are greatly damaged in its upper portion, which would not have occurred from someone breaking in from below. Furthermore, researchers Maracciolio and Rinaldi observed that the damage in this section shows no sign of chiseling, in contrast to the chisel marks within the well shaft leading to the upper entrance. The damage to the mouth of the well and its adjacent block are from hammering, demonstrating the contrast between how the well was constructed versus how it was opened. And what of the final possibility that the builders managed to close the upper well mouth from below, still using the well shaft as a final escape route? Looking at the upper entrance, it seems designed as if to make this task as difficult as possible. You can't slide a block down from the bench itself because it would tip over before falling into place. The size of the block would be more than half a cubic meter, up to 1350 kilograms or 3,000 pounds. The only remaining option would be to pull it into place laterally, but the inner workspace is so small that only 1 or 2 workers would be able to maneuver it. This presents so many problems that I don't think it's necessary to mention them in detail. If you want to design an opening that can be closed from below, you do it just like you see at the bottom of the ascending corridor, with a nice smooth grade and a soft landing for heavy plugging stones. The Great Pyramid already does this, and so suggesting the builders couldn't close a well-designed corridor from below, but were able to accomplish this for an awkward enclosed space with sharp angles, doesn't make any sense. The well shaft was certainly sealed before the granite plugging stones were lowered into place, and it did not serve as a final escape route for workers. The damage to the upper well mouth is evidence of breaking in from above, and so the well couldn't have been the first point of entry for plunderers to gain access to the upper chambers of the pyramid. I feel confident in these conclusions, and it's important knowledge to possess when examining the question of how the pyramid was first violated in the ancient past. Retracing the steps and methods of the original robbers has been my fascination for a long time. With this examination of the well shaft, along with my previous video on the prism stone, we are now ready to properly investigate the robber's tunnel. It will be my pleasure to show you exactly how I think the Great Pyramid was first entered, why the robber's tunnel is so accurately designed, and the logic of looting the pyramid as quickly and effectively as possible. And for those of you who think they already know these answers, I promise an entirely new take on the robber's tunnel with unexamined evidence written in stone. Thanks to everyone who watched this video to the end. Please subscribe to the channel to see more of this content. Give a like or comment as you see fit. And above all, remember to ask your friends if they take their history for granted. Welcome to History for Granite. Join me to explore ancient Egypt. Together, we'll uncover secrets that only stones from antiquity can reveal. Please subscribe to the channel to get notified when new videos are published, and thank you so much for growing the channel. The Great Pyramid of Giza has always attracted curious minds to explain how exactly this monumental stone structure was built over 45 centuries ago. The fact that it remains the tallest man-made structure for about 4 millennia is almost unbelievable. It's no wonder that the engineering required to raise all those massive stones so high is a problem that has fascinated humanity throughout history. So interesting is the question of how the pyramid was built that there are more theories about its construction than I can manage to keep track of. This tradition of inquiry goes all the way back to Greek historian Herodotus in 450 BC, who remains the earliest written account explaining a method of its construction. Herodotus claimed that the pyramid was first completed as a stepped structure, just like the earliest large pyramids at Saqqara and Mudun. Afterwards, a series of wooden machines on each tier would raise the final blocks using the mechanical advantage of a lever. He also claims with certainty that the pyramid received its final smooth dressing starting from the top down to the bottom. Modern historians assume that Herodotus received this information from the local Egyptian guides who had embellished or invented much of what was communicated to him. After all, they too were living in an era 2,000 years after the pyramid was constructed and would be left to speculate a great deal. Indeed, some of the other information contained in Herodotus's account is now reliably refuted. Some pieces of his explanation may be factual, but it cannot yet be determined which parts are the truth. Modern archaeology has given us remarkably few clues about large pyramid construction techniques, and so the gap between what is known and what is possible is frustratingly large. The only building technique that most everyone can agree on is the employment of ramps to drag the blocks upward. There remain a few isolated examples of ancient Egyptian construction ramps that were never dismantled. But the size, slope, quantity, and path such ramps might take on the Great Pyramid is highly controversial, and there is nothing close to a consensus about them in Egyptology. A recent and innovative proposed method of construction comes from French architect Jean-Pierre Houdin. In the early 2000s, Houdin developed a comprehensive construction model for the Great Pyramid using an internal ramp after having received the suggestion from his father Henry, a retired civil engineer. This work culminated around 2008 when Houdin co-authored a book with Egyptologist Bob Breyer presenting the idea of an internal ramp to the wider public. There was also a documentary made about this collaboration titled Khufu Revealed, and it's one of the more enjoyable stories told about investigating the Great Pyramid. You can watch it on YouTube, and I've linked it in the description. Just recently, on October 25th of 2022, Houdin published a long-awaited update to his Great Pyramid construction theory in a 154-page paper on academia.edu. I've linked that paper in the description as well. This new paper incorporates data and analysis from the Scan Pyramids mission, which in 2017 announced the discovery of several hidden empty spaces within the Great Pyramid. These spaces include a corridor-like void above the northern entrance, an enormous cavity known as the Big Void above the Grand Gallery, and a small void high on the northeast corner, like the notch and cave that are visible lower on that northeastern side. With this new paper of Houdin's now published, it's a good time to take a closer look at his ideas. But the story of Jean-Pierre Houdin is far more than a novel approach for a ramp to drag blocks upward. It's a story that touches upon all of the problems Egyptology has with gatekeeping and that most fundamental question of who gets to tell the story of the pyramids. An extremely concise synopsis of Houdin's main ideas are as follows. The Great Pyramid may have been constructed using an internal spiral ramp in combination with an external straight ramp on the south side. The external ramp would only reach about 1/3 up the pyramid and be responsible for transporting the heaviest granite and limestone beams that make up the ceilings of the upper chamber. The Grand Gallery, opposite the external ramp, could leverage its size and slope to hold counterweights on a sled. The weighted sled would use ropes to connect the largest blocks and assist hauling them upwards. Following completion of the King's Chamber, the internal ramp would facilitate the building of the upper 2/3 of the pyramid without needing an excessively large external ramp. These two concepts, an internal spiral ramp and the Grand Gallery counterweight opposite an external ramp, are Houdin's most important ideas. His construction model has other details, and we'll analyze some of those as well, but the ramp design and counterweights are the core of his theory. These two main ideas solve some of the largest problems faced by the builders of the Great Pyramid. The internal ramp removes the need for a prohibitively large external ramp. It also would allow the pyramid geometry to be constantly checked, which would otherwise be obscured by a spiraling external ramp. The straight external ramp opposite the Grand Gallery counterweights allows the largest blocks to be elevated onto the pyramid without needing to change direction or be hauled by 600 workers per block. Combined human strength faces logistical problems when scaling to numbers that high. Jean-Pierre Houdin's ramp concepts were innovative, but they were also supported by a reasonable amount of physical evidence that is plain to see. The 5th Dynasty Sun Temple of Niukhara has a very clear internal ramp structure, so the building concept is present in the archaeological record. Also, the Grand Gallery has visible scratching and staining marks along its lower sides, and these could only be caused by a great deal of repetitive force. But despite the worthiness of his ideas and the amount of detail presented by Houdin, Almost everyone in academic Egyptology ignored or dismissed his theories out of hand. It was only Egyptologist Bob Breyer, a specialist in mummies with a little connection to the pyramids, who was willing to give Houdin consideration and help him get the access needed to further his work. Breyer was granted access to climb the Great Pyramid and document the notch and adjacent cavity on the northeastern corner, which corresponds to where Houdin theorizes the internal ramp would have made a turn. Prior to Houdin, nobody had presented a plausible explanation for these interesting features. After this pyramid climb, however, Houdin was denied permission to follow up with thermal camera inspections within the cavity. The Arab Spring Revolution in 2011 also created enormous complications. It would mark the end of his official collaboration with institutional Egyptology. But while Houdin was greatly constrained with his ability to continue research, his ideas were popular enough that scientists began contacting him about methods to investigate further. The most important method proposed to further investigate the pyramids was muography. This allows for the detection of internal spaces within the masonry based upon how many muon particles either pass through or get absorbed by the stonework. The culmination of the collaboration between Houdin and a group of physicists and engineers from around the world was the Heritage, Innovation, and Preservation Institute, founded in 2015. This HIP Institute led a consortium to launch the Scan Pyramids mission, a scientific expedition using non-invasive scanning techniques to analyze the internal structure of the pyramids. But the Egyptian Ministry of Antiquities is very protective about who it gives permission to conduct such research. And Houdin writes in his new 2022 paper, quote, "The only drawback, the mission had obtained its authorizations under the condition of being agnostic, and that the data of the possible discoveries being put at the disposal of the researchers for free. Consequence for me, I was deprived of participating in the mission because of my work on Khufu's pyramid, and I will not appear in any document published by Scan Pyramids." End quote. Houdin elaborates that the mission of investigating the pyramids and the opportunity for discovery was more important than any personal credit he might receive. But as the old saying goes, no good deed ever goes unpunished. And a self-described scientific committee led by former Minister Zahi Hawass was appointed to oversee the work done by Scan Pyramids. Here is Hawass explaining the process during an on-site visit of the mission.
When you have a report of the result of the work here, you should present it to the minister, and the minister will give it to the committee,
the scientific committee, to be evaluated.
In 2016, the mission released its first discoveries on the Great Pyramid, including a new hidden cavity high on the northeastern corner and a void behind the chevrons above the pyramid entrance. Here's how Zahi Hawass described the Scan Pyramids mission right after these findings.
As the interior ramp came from a French guy who knows nothing, because there is no evidence. Give me one evidence to support this. Actually, the Scanning Pyramid project, most of it is to support his theory.
I must say, it is unfair that Hawass prejudiced the Scan Pyramids mission based upon his personal opinions of Jean-Pierre Houdin, who had recused himself from participating in it. That is not the scientific method, despite the name given to Hawass's committee. The Scan Pyramids mission would go on to detect a huge cavity above the Grand Gallery in the Great Pyramid, perhaps comparable in size and orientation to the Grand Gallery itself. These findings of the Big Void were presented to Hawass's committee on September 13, 2017. Houdin writes that in response to the report, the committee imposed the following instructions. 1. That no media disclosure was permitted at this stage. 2. The results must be published in a peer-reviewed scientific journal before being revealed to the media. And 3. The Scan Pyramids mission could not continue scanning work unless the first two instructions were complied with. These conditions would set the Scan Pyramids mission up for failure for many reasons. It frequently takes up to a year to get a scientific paper published, and it would not be easy to keep such a huge discovery secret. However, due to the top-level expertise of the Scan Pyramids scientists and the significance of the results, The journal Nature agreed to fast-track the paper, and the results were reviewed and then published on November 2nd, 2019. The entire world was then captivated by the announcement of the Scan Pyramid's Big Void, and it was truly a landmark moment for the pyramids of Egypt. It's easily the most important discovery at the Great Pyramid since Howard Weiss opened the so-called relieving chambers in 1837. But while the world was enthralled by this surprising discovery, a cohort of academics and Egyptologists were quite saddened. David Lightbody, who would later publish a paper questioning the Scan Pyramid's results, posted this 4 days after the Big Void announcement. Quote, "It's been a very tough few days. Although I love Egyptology and archaeology, at times it has caused massive headaches and heartaches for me and for people I know. The last few days have been one of those times. However, today it seems that it just might have been the case that it's darkest before dawn." End quote. Later, when Lightbody opened his paper titled Questioning the Void for feedback, other researchers found that he simply deleted comments which disagreed with his analysis. I know we've wandered away from Houdin's theories, but the Scan Pyramid's Big Void is the most important part of this story. It's necessary to highlight how notable critics have used the pretense of science to disguise their own personal agendas. Sadly, this practice is not uncommon in Egyptology, and this bad behavior gives other biased individuals an excuse to dismiss scientific archaeology that is essential to understanding the pyramids. Circling back to the Big Void, it is this discovery that is the central piece of evidence for Houdin's new update on his pyramid construction theory. In my opinion, the Grand Gallery as a construction ramp was always the strongest aspect of Houdin's ideas. But the original design he presented didn't seem optimal. Most of the largest blocks in the Great Pyramid are above the King's Chamber, and thus the Grand Gallery is not in an ideal place to help raise them that high. In his original model, Houdin needed the builders to keep the roof of the Grand Gallery open so that the ropes could still pass through to the counterweight at a sharp angle. However, the Big Void could potentially resolve that problem. If this void is a single inclined space similar to the Grand Gallery, then it could be used to help drag those enormous stones to the highest levels above the King's Chamber. It's reasonable to say the Big Void is currently evidence in support of Houdin's theory about the Grand Gallery. But even before the discovery of the Big Void, I think that Hawass and others were beginning to suspect that Houdin's idea for the Grand Gallery had merit. It was particularly interesting that in the 2017 book Giza and the Pyramids, there is not a single mention of the so-called Great Step at the top of the Grand Gallery. You would think a stone with such a famous name, placed exactly in the center of the pyramid's north-south axis, would at least deserve a token of recognition in the definitive history of Giza. In fact, the so-called Great Step is the central focus of Egyptologist John Romer's 564-page book titled The Great Pyramid, published in 2007. Here he is on the TV show 60 Minutes, obsessing about it.
When we get to this, which is the masterpiece of the whole bloody pyramid, it's the refoundation of the pyramid. You know, this is the center line. We're setting it up again.
It can only be intentional that Zahi Hawass would omit mentioning the so-called Great Step in his Giza and the Pyramids book, and I think Jean-Pierre Houdin is the reason why. If Houdin is correct, and the Great Step is not a step at all, but instead a trench as it looked over 100 years ago, then Egypt's Antiquities Department has greatly damaged the Great Pyramid with this inaccurate restoration. A trench would better facilitate the passage of ropes through it, rather than a step which would cause excessive friction. In all likelihood, the Arabic tradition of calling this stone the Great Step is what led the Antiquities Department to assume it was a step and that the upper portion was missing due to damage. Zahi Hawass is the former director of the Ministry of Antiquities. Many restoration jobs were conducted by the ministry, including some in the 1990s under his direction. This gives plenty of motive for Hawass to reject Houdin's ideas because they implicate the ministry in destroying a critical piece of history. But rather than acknowledging his conflict of interest and recusing himself like Jean-Pierre Houdin, Zahi Hawass had no problem asserting his authority over the scientific process.
This is why I'm heading a team. And with me are 3 foreigners who are expertise on the pyramids, and we are correcting them.
In that context, it is no surprise that institutional Egyptology hasn't engaged with Houdin's ideas in a serious way. Now, I will say that after reading the new update to Houdin's theory, I was a little disappointed. The greatest strength/weakness of Houdin's approach is that he proposes an optimal method of construction that reduces the need for manual labor. But the ancient Egyptians had an abundance of conscripted manual labor available. I find it unlikely that the builders would overcomplicate the pyramid design just to cut back on required manpower. In Houdin's latest model, he adds vertical counterweights like the kind you find in a modern-day elevator to help power the pulling force of the Grand Gallery mechanisms. I find this solution unlikely, and I know of no archaeological evidence to corroborate it. Surely the big void acting as a second Grand Gallery with the assistance of human force would be sufficient to get the job done. In Houdin's defense, he is attempting to account for all of the Scan Pyramid's data, which just isn't sufficient to model hidden structures yet. Houdin writes that in 2017 he suffered a heart attack. It may be that given the glacial pace of Egyptology, he feels that this could be the last new data he has the opportunity to work with. Therefore, he might be taking his theory as far as he can now, instead of waiting for more information. One aspect of Houdin's construction model that I've always found intriguing is the staging area for the largest blocks, 43 meters high, on the pyramid's south side. In his latest revision, this staging area is still used, but needs to be elevated in several stages to about 58 meters high in order to utilize the big void as a counterweight space. The unusual damage to the pyramid's southern side is evidence that this part of the pyramid had a less durable construction method. The filling in of the staging area would be a potential cause. There are a few details in Houdin's theory that I still find highly illogical, such as the insistence that every casing stone would be dressed fully smooth before installation. There are many examples of both granite and limestone casing stones that were installed with the outer face undressed. Houdin points out that the Tura limestone is soft when excavated and then quickly hardens. But while cutting the stone is easier at the quarry, transporting stones with sharp edges would be prone to breakage during transportation. This could easily be more costly in the long run. The countless patched casing stones at the bent pyramid prove how often such damage could occur. The small shafts emanating from the King's Chamber and Queen's Chamber are another aspect of Houdin's theory which I am confident is incorrect. He claims that the shafts would be used to amplify sound for workers coordinating the counterweights. But the Queen's Chamber shafts weren't originally open at their lower ends. Houdin's idea that the blocks surrounding them would be movable so that they could be opened and shut is quite ridiculous. After all, if the King's Chamber shafts were left open, there can be no justifiable reason why the Queen's Chamber shafts needed such open and close functionality. The theory of an internal ramp is not elaborated in Houdin's latest paper, but he foreshadows 2 additional papers which probably discuss it further. But after reading this latest publication and thinking about it more, I believe I can improve upon Houdin's model. I'm still not convinced for or against the idea of an internal ramp, but here's the change that I would make. A spiraling ramp doesn't need to start at the bottom of the pyramid's southern side. It would be much more efficient to begin this ramp in the staging area where the straight external ramp ends. This way you don't have to drag blocks an extra half a kilometer to reach the same elevation. Houdin begins his internal ramp at the bottom of the pyramid because he's attempting to explain how other hypothetical chambers and corridors might integrate with it. But I don't believe such structures exist, and I don't think the workers needed an escape route to seal the chambers beyond what has already been discovered. I find it notable that physical evidence for a spiral ramp structure, such as the northeastern cavities, are only found high on the monument. These anomalies are not found in the lower third of the pyramid. Furthermore, the masonry where Houdin supposes the internal ramp might begin shows no signs of unusual design. Finally, Houdin's idea that the external ramp could have been recycled to make the upper pyramid masonry isn't as practical as it sounds. Constructing the Great Pyramid would have generated enormous amounts of small limestone chips. This wasteful byproduct could have been used for the external ramp, consolidated with stronger retaining walls on the outside. Indeed, that is the design we find for ramps in the archaeological record. Thus, any spiraling ramp, whether internal or external, would be more efficient by starting from where the straight ramp ended. But no matter how accurate Houdin's extremely detailed model ends up being, we are in his debt for the monumental effort to push study of the Great Pyramid forward. The discovery of the Scan Pyramid's Big Void began with his desire to solve a mystery of the Great Pyramid. It took incredible perseverance to take his curiosity that far. Much of Egyptology was aligned against his research, and even today this accomplishment is casually dismissed. For example, in response to Houdin's latest paper, Egyptologist Sarah Parcak wrote, quote, "The void is a noise echo, common issue. The whole Scan Pyramids thing is utter nonsense. I feel bad that Houdin wasted his time." End quote. Everything within that statement is lazy and false, and one wonders how Houdin could put up with such attitudes for over 20 years. A noise echo can't be a common issue for muography in pyramids because Scan Pyramids is the first mission to detect anything with it. The Scan Pyramid's results showed no echoing from any internal spaces within the bent pyramid as a control, nor from the chambers within the Great Pyramid. The muography was conducted by 3 independent teams using different angles of detection with different scanning methods. All scanning teams reached a 5 sigma level of confidence. And a noise echo isn't even what David Lightbody's feeble questioning the void paper claims to cause the big void signal. However, when it came to her own research, Sarah Parcak lamented the dismissal of new technology.
It has been a struggle. Just because the technology is so new. And when you show people facts and figures about sites you're finding or show them things that you're seeing, people kind of roll their eyes and say, well, here comes yet another gee whiz technology that, aims to solve everything.
In 2011, Sarah Parcak claimed in international press to have found 17 hidden pyramids. 17? 17 pyramids using satellite imagery. 11 years later, not a single one has turned up as a pyramid. No matter how outlandish any part of Jean-Pierre Houdin's theory might be, institutional Egyptology makes claims that are far more ridiculous. There's still a lot of work to do before we can finally uncover how the Great Pyramid and other large Egyptian pyramids were built. Houdin has given us an idealized model of how they might have been constructed, and there is much to learn from that approach. It has led us to the big void and the confidence that there is a great deal more that can be learned from further study. The real lesson of the story of Jean-Pierre Houdin and the Great Pyramid is that the work is never finished. It is still worthy of our time and consideration, an unprecedented achievement from antiquity that deserves further investigation. There are real solutions to its mysteries which are solvable, and only by emulating the dedication of Jean-Pierre Houdin can we hope to bring them to light. Thanks to everyone who watched this video to the end. Please subscribe to the channel to see more of this content. Give a like or comment as you see fit. And above all, remember to ask your friends if they take their history for granted. And today in the workshop is a Sony Gigaduke model NAC HD1E, released for the connoisseur of piracy. This model was launched in 2007 for a hefty price tag of £700, but for that you do get a good tuner, CD player and a 250GB hard disk. Up front it's all swanky push button controls and a single drawer for the CD player. Presumably this has got quite a swanky display, but I haven't seen it work yet. I'm not too busy around the back. There's the antennas, analog input and output, and various digital things. And this one has been delightfully customised by Gary in monochromatic marker pen, contrasting beautifully with the OEM silver finish. Not sure if he's into astronomy or looked heat lamps or was smoking pot, but that's not how you spell infrared. Now I'm not quite sure what's supposed to be wrong with this one, so I'm going to power it up. Luckily this one's actually got a decent plug on it for once, so in it goes. And on it goes. Well, it don't look very happy. Flashing standby lights, never a good thing. Okay, so it's dead. Well, not totally. We saw inrush current and we heard the relay click on and off, which sounds like trouble, but to cheer me up, I have invested in a new corded screwdriver. Look at that. Ooh. Well, there looks to be quite a lot of stuff in here at first glance. You can easily recognise this 3.5-inch hard disk, all 250GB of it. And it's all connected together using this 40-pin IDE cable, the staple of many computer build in the 90s and noughties. And a horrendous digital board here with lots of chips with no legs. These BGA things are the stuff of nightmares. Let's hope there's nothing wrong there. The largest board at the bottom contains a few power supplies, and all the analogue stuff lives here, I reckon. And here's the main power board. It's got switching regulators and big chunky diodes. That'll be a bridge rectifier there. This must be the main power, but this thing isn't that powerful, so yeah. And this will be the main power transformer, and this will be a little switch mode standby power supply. Now typically when these things are dead, it is the standby power supply, but I don't think so in this case. There's not a lot going on with the standby power supply. You've got the mains in, a mains out, and this little plug here with 4 wires on. Not a lot. Just want to check that digital ground is actually attached to the chassis. And it is. That's good, because I can just ground it to the scope. So I plan to measure 3 things all at once. So I'm going to stick 3 probes in. I've got the schematics of the little power board here. We can see here we've got a 4-volt output for the standby. That's easy enough. Ground. There's the output for the relay, which is coming from an external board, and we've also got another input here, which is to shut the thing down. Literally just clamps out the voltage. Wow. So I'm going to be looking at the 4-volt rail, the relay, and the standby off drive. It's probably easier to do it on this board here, a bit more room. So I can find room in the plug, that is. It's a little bit cramped, so actually I'm going to do it there instead. So, here goes. Okay, what this is telling us, the yellow trace is the 4-volt power supply coming alive. Nothing wrong there. The green trace is the relay. So the relay's been turned on and then straight off again. Why is that? So we see the relay is actually powered on this main board here. Follow the traces down. It's ultimately turned on by this transistor there, which is controlled by these here. So the power on signal, which goes into this bus here. Follow it down and look for power on again. There it is. It's controlled by a microcontroller, IC401. However, I am drawn to this bit here. It says emergency. What is that? So that goes back up to this bus. Follow it back up. Emergency's there. We follow this back down, follow the trace. There we have it. It goes to the power board. That is worth investigating. Pin 7. Looking at the schematics for the power board, we see pin 7 is the emergency signal. We follow it through. It goes up here. What does it do? So there's a Zener diode there. What's that? 15 volts going to a rail, which is 3.3 volts. So anything over 15 volts is going to put some juice on here. We follow it down. Same again, 15 volt Zener diode. This is a 5 volt supply. Again, same pattern. 15 volt Zener, 5 volts, and again 15 volt Zener and a 12 volt rail. So anything over 15 volts is going to drive the emergency line high. I can pull this probe out here because nothing happened on that pin and stick it in pin 7. If I can get the probe in, bit of a snug fit. Okay, going again. Well, that's very interesting. We don't see anything happening to the blue trace.
Well, that has thrown me a bit. I was fully expecting that emergency line to have gone high, but it didn't. I still think it's a power supply, but what's wrong? Well, just to sense check this, I'm just going to disconnect the AC power to the board. See what happens. It's definitely that relay. Yeah, I can feel it. Definitely that one. Well, this is interesting. So the 4-volt rail is staying high. We've seen the relays being turned on and off continuously. I can pull some of these probes out because I think they're telling me all they're going to tell me. Well, I'll plug that AC power back in because I'll be honest, that's not massively helpful being removed. I'm just going to unplug this connector, see if we're feeding something bad. Power on. Well, that's made no difference. I'll do this one as well. Power on. Still no difference. There's only one connector left here, might as well unplug that as well. I doubt it's going to work though. No, still straight on and off. I need to think outside the box here. I need to force that power board to stay on. Now it's fed from this transformer, so I think I can just disconnect this and power it directly. It just so happens I've got a mating connector for this, so I can power it up to these crock clips. Let's see what happens now. Well, there's no dramatic smoke, that's a good sign. I'm just going to move the chassis ground to the multimeter. We're just going to probe the output voltages on here. The 5-volt rail is on D922, which is here. And there we have, 5 volts, perfect. There's a 3.3 volt rail on D912. 3.06 volts, that's, it might be okay. Then D942 is a 12 volt rail. There it is, close enough. And there's a second 5 volt rail on D932. Oh. That's a bit high. 24 volts. Oh, what's wrong there? Well, it's suddenly become apparent why it shuts itself down. So let's take that power board out. There's only a few screws holding this board in. Shouldn't be too bad. One there. Another one here. A little bit cramped up there near all the cables. Must undo this cable here. Easy to undo when it's fastened down. There's that screw out. And just one annoying plastic clip to deal with. Come on. I think that's out. That's not how it's supposed to come out. Well, it's clipped a bit mangled. I wonder how that happened. Someone's been in here before, haven't they? Yes, I think people have been in it. Look at this nasty soldering. What is that? We've put a link across, but it's already off the track. Why? This has been isn't it? Oh yes, I see it now. Yeah. Uneven length legs. Okay. These aren't new, these are still glued in. What about these? Oh yeah, more dodgy soldering. Yes, okay. But can dodgy soldering cause a 5 volt rail to become 24 volts? This is the schematic of the 5 volt circuit, and you can see here we've got 22 volt rail here, and on pin 2 you got the 5 volts should come out of there. So we've got two scenarios. Either this is shorted on this device here, that'll cause it, or if it's not shorted, this thing's switching it deliberately. You can see quite easily on this board that there's 4 identical circuits, well pretty much identical, just give different voltages out. You can see the controller chips here, built-in controllers and transistors. Nice 5-pin package. Let's have a look for IC932. And there it is, there's pin 1, measure resistance to pin 2. There's no shorts there. So as there's no short between these two pins, this controller must be working its nuts off to get the voltage level on the feedback pin that it's looking for. Now it's supposed to be 1.3 volts here, which will be derived from the real output voltage and divided by this resistor network here. We should check this out. There's pin 4 there, got a little trace there, goes all the way to these little resistors here. Found them. I'm going to need the microscope for this. Well, here's the resistors in question, and what's this? That doesn't look very good. I'm not sure if it's right. Let's look at this circuit here. Ah, it's connected. Definitely. And this one. Oh, there we go. Track damage. In fact, this soldering is very blobby. What about this one? Also blobby solder, but not too bad. So I'm going to tidy up these blobby solder joints and then fix those tracks. Probably best to remove some of this solder. There's rather a lot. Even though I'll have to put some back on. look too bad. These aren't terrible, just not very neat. I'll skip that one for now. It's as if this leg should be bent over that way to touch onto here. That would work. It is soldered down still. Just lift it up with the iron if I can. Push it slightly to the side. Let's put a bit of fresh solder around here. Not the tidiest job, but I reckon that'll work. Just loosely pop it back in here. Pop one screw in. Just connect the transformer output. And we'll see if that 5 volts is back to what it should be. Okay, D932. 4.76 volts. Well, that's better than 24 volts it was before. Certainly a lot closer to the 5. What else have we got? So we had 12 volts on here. That's still good. 3.3 volts on here. Oh. Like this one. That's still 4.76 volts. 5 volts as well. Okay. Well, the 3.3 volts is very important on here, and I don't know where it's gone, but I've got a feeling it's more of an open circuit than a short circuit because there's a tiny amount of voltage left. And we can see on the schematic, we scroll up past the 5 volt converters, and here we have the 3.3 volt one. It's exactly the same circuit. There can't be much wrong with it. I suspect it's missing the input voltage. It's all come off the same supply rail, look. All the way down here. All derived off the same 22 volts. Well, I'll unplug the transformer again. I'm glad I only put the one screw in. And there's IC 911. Pin 1 is there. Oh. Bet you there's the problem. You can see there's been trouble from pin 1. Look at this. There's already been a repair there. And it should be connected to these links here. But that looks a bit torn to me. Look at that. The track's flexing. If I measure resistance from here to there, 37k. 47k. It's getting worse. I think I'm going to take the old repair off and start again with it. Looks like it should be connected across all 3 places really. From here, here and here, because this is basically disconnected from everything. Nasty. I'm going to solder a bit of tin copper wire onto there. And bend it round here. Solder a bit there. And hopefully let's check we've got continuity. Go from this link to pin 1. Perfect. We'll try that again. Let's chuck it in again, see what it does this time. There we go again. So check the 5 volts. Yeah, okay. Next is the 12 volt rail. That's good. 3.3 volts. Okay, it's 3.05, is a bit low for my liking, but it's there. And the other 5 volt rail. Okay. Actually, it's probably reading slightly low because I haven't got all the grounds connected. Probably not the best connection. Probably worth connecting all these now. See what else is wrong with this thing. the transformer back under control of this relay. Well, here goes, but I'm always a bit wary of these power supply faults, especially when it's tried to stick 24 volts up the 3.3 volt rail. That's not very healthy. Oh. It's dead. No standby light? Nothing. Have we still got the 4 volt standby supply? Well, not really. 2.24 volts, that's not working. Well, it was working. Let's take it out and have a look. Just going to unscrew the FM tuner module. That makes access a bit better. There's another one of those annoying plastic clips here. Should be good. There we go. Oh, we got more bodging going on. All the legs of these chips are all being bent over to make contact. They've ruined all the pads there. And all this going on around here. Looks like it's had caps again. So what's wrong with it now? We'll get the microscope out and have a look at this reworking that's been done. Well, all the pads on this chip are gone, but to be fair, it looks electrically sound to me. This side, yeah. This is good and solid. This is where the main capacitor is, the 400 volt one. Yeah, no problems. It's not the tidiest job, but I don't think the electrons really care. Just having a look for anything that looks a bit dry, like we've got some funny shapes there. I don't know if that is a dry joint or not, but I might touch that up. The feedback for this is comes from some opto-isolators for these resistors here. Again, they look good. But hello, this doesn't look good. This is loose. I don't know why that's going to be reworked. Anywhere else? A favourite place to check is actually on the connectors where all the strain's going on. So that's over here, and oh, look at that. Pin 1. That looks a bit iffy, doesn't it? Broken ring all the way down there. I wiggle the wire. Oh, look at that. I think I'll resolder the whole row. Just trying to find that diode I saw. There it is. Okay, and this part here. So I'm not sure what's going on there. I'm going to actually desolder this one. Took the rubbish off. Well, there is at least a whole ring around it. That's better. Just going to have a scout around and see if there's any other loose connections. But it all looks okay so far. Actually, I'm a bit intrigued why they changed this large cap here, 10 mic 400 volts, but they haven't changed this one. So 1 mic 160 volts. Let's have a look. Just drop the ESR meter across here, and oh, it doesn't even register. Barely. God, that's some bad order. Okay, I'll be replacing that one. Rather obnoxiously, they've bent the legs over. So I'm going to use the desoldering tool to straighten them first. Let's get that solder to melt. Lift it up straight. The same over here. And get at it. And on that rather comedic twist of fate, it looks like I've torn the track off as well. Damaging circuit board tracks happens quite a lot, especially when the circuit boards are cheaply made, which they often are, and even worse when they bend the legs over. It doesn't help. I'll be showing you how to put these right in my new training course and online community, so if you want to check that out, the Mend It Like Mark community, you'll see the information on the pinned comments. Anyway, we'll get back to fixing this. So I'm going to bear a bit of the solder mask off. Let's dig through there, get some bare copper. Well, in goes the new capacitor. give that a whirl now. Get it back in. So we'll try it again. That's a bit better. The hard disk should be buzzing its nuts off as far as I'm concerned, making a lot of clicking noises, and it's silent. I heard the head click when it immediately powered up, but there's nothing now. Let's check with all these voltages still. There's our plus 5 volts, that's good. 3.3 volts, good. 12 volts, and over here, another 5 volts. No problems there. The IDE connector goes to this board here, so this is where all the silicon is, and I reckon this is where the problem lies. So it's difficult to find your way around this, so I'm going to systematically just disconnect things, see if it changes its behaviour. This is to the digital audio socket. Take that off. Let's try that. And now there's no display, and still no activity from the hard disk. Just want to put it back in, so that's not changed it. Next news cable to the IDE connector is this one. This one actually goes to the display, so we definitely won't get a display now. So we'll give that a whirl. Still no action. Damn. I'm just going to probe these power supply rails here, see what's going on. Oh, it's not quite what I expect to see. They're all showing the same as well. That one's fairly stable. Okay, yeah. Yes. We'll check these caps here, because I have seen these go bad before. Well, that's measuring okay-ish. This one's terrible. Wow. This big one. That was measuring good, okay. This little one here. This one's no good at all. I can get in here. That was good. Over here, that was perfect. Must be very good. Still got some voltage across it, I guess. How about this one? Also perfect. And then finally over here, I can get the probe on. Yes, fine. This little cluster of caps here near the IDE connector, pretty bad. Hopefully that's the cause of the trouble. So let's take this ribbon cable off here. Get that out of the way. I don't want to melt this plastic connector, so I'm going to put a bit of Kapton tape around it. Just to offer a little bit of protection. A bit over the top. And another piece again, just to sort of double line it really. Oh, it's stuck. Try and keep that in tight. Just going to warm the board up with a hot air gun. So these being power supply caps, of course, they'll be attached to the ground plane, which is probably some crazy whole layer on this. It's going to take a lot of heating up. And I don't want to tear the pads off this. We've seen a lot of pads being torn on this machine already. Try going in with the soldering tweezers. I don't have 1000 microfarad caps, so I'm going to skip that one. It does make it a bit awkward getting in here though. We'll put a conventional line down there. Alternate side to side. There you go, that works. So I'm going to put a little bit of flux on these, so I can get this solder flowing nicely. Just add a little dab of leaded solder on top. cap on there. Just need to tack it on. Press it down a little bit. Okay. Same thing. Tack it on. I think I can peel that off now. Plug this back in. It's always good when it still fits. You can plug the display cable back in as well. Oh, we'll go for it again. And there's no display. What have I done? If I look at the schematics on the LCD board, scroll down here. See if I can find that connector. And here it is. 9 pins. We got pin 3 is the serial clock, pin 4 serial data, power supply, and pin 5. Let's see if it's present. It'll be easy if I tip this thing over. Okay, pin 1, that's the backlight contrast. That's floating around 1 volt. Okay, probably right. Pin 3. There's our serial clock. Nothing wrong with that. Pin 5 is the power supply, 5 volts. Yeah, that's good. Pin 2 is LCD power. Yeah, 3.3 volts, good. And then over here we've got the data. And there's some data. Could it be missing backlight supply? Something silly. Let's change the scale on there. That's like 24 volts or something. Nothing wrong there. There's no activity from the hard disk and there's nothing on the display, and I'm not sure why. I'm going to park this video for now because other things need repairing. But if you're interested to find out what I'm going to do next with it, you might find out on the Mend It Like Mark community. Check out the comments for details. And today on the bench is a Pioneer DVL919 Laserdisc player. Yes, video Laserdiscs. They came after these and before these. But these never really took off as a format in Europe because you couldn't record on them like the old VHS videos. And the Laserdisc players were expensive too. And this model's rather late to the party. This was released just after 1995. And it cost £900. About 4 or 5 times more expensive than a video cassette recorder. And being a later model, it plays DVDs as well, as you can see with the logo right in the middle of the tray. And this one boasts some high-end digital audio specs. And rather curiously, there's a separate eject button for DVDs, CDs and Laserdiscs. Why is that? And the back of this isn't too complicated. It looks worse than it is, but it's mainly just writing. And not an HDMI socket in sight. It's got a pair of SCART sockets, remember those? And various video outputs. And it comes with a rather swanky remote control. With hidden buttons. Fancy. I was doing this thing. I'll tell you what, that back in present display is looking pretty dark. Is it dimmed? No. I don't know if I can do anything about that. That's a new display and I doubt I'll get one. So I guess this is going to be rather clever. There's a CD drawer. Pops out just a single CD drawer. How about Laserdisc? Wow. So it turns out it holds 4 different size discs, anything from 3-inch, 5-inch, 8-inch and 12-inch. Although it does warn you not to put more than one in at a time. Now I'm told that this thing does actually play, but it throws the odd tantrum. So I'm going to take the lid off because the technology is really cool. Now that's one monster mechanism, and it's got that much weight, it's got springs to help hold it up. You can just about see the mains power supply under here, big switch mode job. And the other side, that's for the circuit boards. And there's a lot of Pioneer silicon here, look at that. And what's this, a Fujitsu? I reckon that's a microcontroller or something. Got a lot of legs. And that board will be for decoding the DVDs, which is quite an intensive operation. Conversely, the bottom board for the Laserdisc player doesn't require anywhere near as much computing power, so it's much older stuff down there. And that's because the video data stored on the Laserdisc is actually analog. The Laserdisc is very similar in construction to the standard audio CD, only it's a lot bigger. But inside here there's an aluminium layer, and it's actually got the data, which is like pits and spaces, pressed into it. They can squeeze just about 1 hour of video on one side of these, so it's double-sided, so you can get a whole film on, almost. Now the owner tells me that it works, but it only plays half a film. So I'm going to plug it into the monitor with the old SCART connector and give it some power, obviously. Let's get that massive tray open. That's exposed more of the power supply. It looks to be, visually, in very nice condition. I don't think it's had a hard time. And this thing's actually got 2 lasers, one at the bottom and one at the top. But it's not for playing both sides of the disc, you know. Although that is a requirement, because these are double-sided. So in it goes. Press play. Just look at that run out on there. Now that tells you how good the laser servo systems are. It's constantly looking at the focus on that, and the laser lens will be tracking up and down just in time with that. I don't think I can see it though. But it definitely works. The music dates it a bit, but yeah, decent picture. Not the best, but it'll work. I can't sit here all day watching this, so I'll skip through it a bit. Oh, it's a bit jittery. You can really see it slowing down now. This will be a constant linear velocity player. This is the last track on this side. It's going to change over now. I notice in the fault the sledge motor's not going, and I don't know why, but what you can see is the lasers focusing, so they call it radial movement. That's trying to slowly move across, tracking the very small track, 1.6 microns, and then it doesn't move and it just jumps back to the beginning. That's why we keep seeing the looping movie. I think we'll power it off with the tray open so I can get it out a bit more easily. The tray should take all these bendy plastic tangs. I don't know if I need this cover off, but it's coming off. At this point it's coming apart like a giant CD player. One thing dropping a screw in a switch mode power supply, it's another one leaving it there. You can normally get the laser pickup out by taking out this guide rod, because it's only held in by one screw over here, and you could undo it, but I think that's going to be trouble. You don't want to tear that flat flex cable. Not on a good laser, no way. And there's not that many screws to take it all out. It's so deep in there, rather comically, you can't reach. Those hard to reach spaces comes Mr. Bendy again. Be a good idea to take this ground strap off as well. Looks like it won't come out unless I take the front panel off as well. Try and bend it up. Wiggle it off. There we are. Although this is stretched like a bowstring, so I better take that off as well. Let's pull that off. There we go. Not sure what this does, apart from stop it being removed. Let's fetch that off as well. See if I can get these springs off here. Funny little hook things. There's one. There's another. Let's undo this cable. This is off the DVD laser. And this one here, I'm not sure what this one's for. It's got to come off. This is the other laser pickup. There's still more to come off. I think this front panel's the next thing to come out. And of course there's a screw right in the middle. How am I supposed to get that out? I need to release these ribbon cables from this clamp here. Otherwise I'm going to tear them off when I've moved this backwards. And that's not what I want to do. Probably helps if I take this carrier off. Pull this clip out of the way. There we go. Just spotted another ribbon cable that needs to come off. Don't that catch him out. See if I can just jiggle it backwards a bit. Yes. At least now I can get to the screw. Now she comes. Aha, I've missed a screw over here. I'm not liking the noise this is making. Smelling a bit too. I think I might need another one. Now in theory I can just pull this off. Will it come out now? Yes. Oh, no it isn't. One more wire. Well, it's left a big old gap, and that was a bigger job than I was expecting, to be honest. So I can more comfortably get the laser pickup out, I need to remove this plate. And it might be as simple as just removing these 4 screws. It's got to remove this spring as well. This plastic part's got to come out. Okay, probably better if I unplug this. Just snap the cable off. And there's our first proper look at the laser pickup unit. Now I want to apply a test voltage on these motor terminals, but I'm not sure what else is connected to here. I think everything's disconnected, but I want to unplug this. Just need to flick this little tab up. Same this side. I'm going to set something sensible like 3 volts. I'll put the probe on there, just touch it and see how it runs. No trouble that direction. Let's see how it goes this way. Oh, it's running off. Seems to be running just fine though. Now knock this down to 1 volt, set it a lot slower, more like how it should be running. Let's try that. No problems there. Let's swap the leads back, see if it comes out. Oh, that's jammed. I do believe we replicated the fault. The motor's pulling current, so I think this is mechanical. So I've got to get this guide rail out, which is just that screw. Well, I do have to say, I I like this cable restraint. That spring-loaded lever. That's very tight, isn't it? Out comes a little screw. Now I think this just slides out. It does. These laser pickups are very sensitive to static, so I'm going to ground myself just to discharge anything I've got. And that's easily done by just touching something grounded. There we are. Any scope terminal is generally grounded. This black plastic assembly is holding the motor on, and it's basically a gear casing for a little gearbox. How did he? I don't see anything obvious. This worm assembly, what does it drive? It must drive another gear, like a worm wheel. Let's just power the motor up again. See it's going round okay. Oh, it's that black rubbish on there. You see that? Bit of grit or something. Let's try it in reverse. I don't see any trouble. Apart from that grit. I think it's just dust or something. Let's see if I can brush it out. I'd say that has. That all looks pretty clean to me. I think I've got to look elsewhere. Something to consider, this only plays up on the B side, so that's running on a different track. So the laser assembly actually runs on this guide rod and drives on this track, which, well, that is a bit loosey-goosey, isn't it? Let's actually mount the laser onto this, as it would do in operation. In there. Rotate the motor there. I think I'll power this along. It's a bit quicker. I'm going to drive this backwards in little pulses like it would do in real use. Oh, it's stuck. Look at that. Oh, no it went. So I can do a bit more testing. I'm going to solder some wires on here. So this time I'm not pushing it with my probes, so that could be interfering with the results. Just going to shove this rail under the power supply here so it's orientated the right way. It's jammed already. That's properly jammed. First attempt. That is going nowhere. Give it a little push, see if that moves it. Oh, there we go. Let's drive it back. That's nice and smooth. See if I can get it to stick again. No. It's as if that's dislodged some debris. I think this thing needs a bit of a clean out. Just going to drive this off the end of the track. I'm going to give this guide rail a bit of a clean down. Let's wipe it with some IPA. I don't want to take the rail off because it's on these delicate plastic mountings and I have a fear that they won't go back on in exactly the right place. Just brush this gear rack off. I can't really see anything in it, but whilst I'm here. Just going to clean these guide bushes out. Well, there is a bit of muck in there, but that's to be expected. Although I'm quite encouraged just how much black muck's coming off here. To this side as well. Oh yes. This could just be a case of old grease. It's nothing like the sort you see on old record players, but this is quite a delicate mechanism. We'll take this little gearbox apart. I might as well do. Everything else has been cleaned. Now that's all apart. So here we've got the gears exposed and I see a hair. Could that be causing the trouble? It's difficult to see what else is there. think these are going to have to come out. I have to clean the grease off them so I can see better. Also put this plastic holder in as well. Spray some IPA on these. And hope this washes the grease off. Let's not forget this little worm gear either. Now everything's been cleaned, you can check it for damage, and yeah, I don't see anything wrong. That's very encouraging. Same with the gears. Those teeth really are pristine. This motor holder assembly. Shafts are all okay. Can't see any cracks or anything. I think we're good to put it back together. And I'm going to re-grease it with this Molykote grease EM30L, especially designed for plastics, I understand. We'll start by putting a little bit of this grease on these spindles. Not loads. That's probably too much. Put a bit in there. Poke the worm gear through here and sit it down there. Pop a screw into the motor and another one. We've got this spring assembly, goes on like that, and just squeeze a bit of grease onto here. I'm going to power the motor up to drive this round. There we go. And just a little bit of grease in these bushes. Just slide it on here. Just engage those little gears. Let's see how it moves. Beautiful. And back again in little bursts. Just going to do the back of this as well. It's a little plastic guide here. Just put a little bit of fresh grease on there. And hang it back upside down. This is looking good to me. I'll just drive it off this track. Takes a little while longer than I want it to. And put the lower guide rod through here. There we are. Just locate the laser and the guide rail in the right places. Pop the little screw in. Take it for a little drive down the track. That's lovely and smooth, that is. Back the other way. Absolutely lovely. I'm going to solder these motor wires now. That flat flex isn't quite sitting nicely, is it? It's better. Now I can reinstall this top plate. Give it a wiggle. Pop this wire back in as well. Then we've got this claw thing, whatever it is. Sits through there like that. Just goes in there and there's a spring on it. There we go. Now I can throw it back in the chassis. And this is the perfect time to remember to put this ribbon cable back in. this little plug here. And the front chassis frame, I think it went on like this. Put this back in the right place. Something like that. Trying to retrieve these springs from down here. There's one. And there's the next one. Bit of a stretch this is. And that's the second one. I've got to get this retaining clamp back in there somehow. I'll drop it in. Get these long tweezers on it. Might be in luck. Yes. And there's another clamp which sort of fell out. And somehow I've got to plug this cable into here. Oh, that's going to be a tight squeeze. But it's in. Sounds a bit easier. So we've got this cable retainer. It's a piece of plastic. Just have to thread that through there. Like that. Where's it retainer? Over here. Also got this grounding lead on here. And this is the cable for the DVD pickup. I'll get this bar back on there as well. Oh, I nearly forgot about this one. Just wiggle this plastic thing on. Got to put the front panel on as well. Just push the cables under here. On this little bag. Then feed the tray in, so I can remember how it goes. Then the front panel cable plugs into here. So I'll take this screw out so I can put the ground tag back on. There we go. So now it's ready for a quick test. Let's hope it works. Oh, that's not good. I think I've broken it. Oh. Let's hope it's just a cable I've missed. So the power supply connector's all in. Although I don't think I even took them out. I've got the power into the board there. This is the mechanism. That's plugged in. I can't see anything I've missed. There's no sockets that aren't occupied that were unoccupied already. How strange. I can't believe I've actually broke it. It's something silly. Ah, how's that for silly? I haven't plugged the laser in. What an idiot. Well, do you think that could be a problem? I'm only hoping I can reach it. I think I can. Yes. Let's try that now. Well, that was lucky. I thought I was in a bit of trouble then. Let's get this thing back on before I put a disc in here. Put this disc in and let's hope it plays. I'm just going to leave that to play a while, make sure it doesn't skip. I'm going to fast forward a few tracks. So that's played through a whole track now without skipping, so big improvement, and I'm pretty sure that's fixed it. So we'll put the covers back on now. I'll start with this little back cover. It just hinges on. 19 screws left. Will they all find a home? And there's 10 screws left for the lid. They must be frightened of it blowing away. Something interesting, these screws are the Japanese industrial standard, JIS, and you need a special screwdriver. It's not that much different, but it fits very well if you get the right thing. But it didn't need any parts, just a clean and some posh grease. Let's hope it stays working. Catch you next time.